Dear student, welcome to the What is series of basic physics. Today in What is series we will discuss about what is thermionic emission. Dear student, please note that the word thermionic is a combination of two words. One is therm and the other word is ionic. So basically the word therm mean heat, whereas ionic mean a combination of positively or negatively charged ion. So collectively the word thermionic mean a relationship of heat with positively or negatively ion, and whereas the word thermionic emission or the process thermionic emission mean the emission of ion by the application of heat. So in thermionic emission, the usually the ion are liberated, the ion are removed from the surface of the metal upon the application of heat. Thermionic emission is known as thermally excited charge emission process. Is defined as the process of emission or liberation of charged particle from the surface of heated metal by a virtue of temperature. So in the thermionic emission process, the charged particles, which may be electron, ion, or they are collectively known as thermion, may be ejected from the surface of the metal if the metal is heated up to a certain temperature, and this process is known as thermionic emission process. The student, please note that in a metal, electron reside on the surface of the metal. They move throughout the surface of the metal, and these electrons are known as free electron. So free electron act as an electron cloud on the surface of the metal. So when the metal is heated up to a certain temperature, then due to a heat, the free electron from the surface of the metal will start to be ejected, or they start to be liberated. Basically they just fly away from the surface of the metal due to a heat. So this phenomenon is known as thermionic emission. Usually the thermionic emission is mostly known for electron, but this process is also valid for ion and as well as thermions. Thermion is basically a combination of negatively or positively ions, and so dear student, in a simple word, thermionic emission is a process of emission of ions from the surface of the metal on the application of heat. Dear student, please note that thermionic emission occur because the thermal energy given to a charge carrier overcomes the function of the material. The charge carrier can be electron, ion, or in older literature they are sometimes also referred as thermion. So now question here is that the student, when a metal surface is heated in thermionic emission process, then why electron or charged ion, they are emitted from the metal surface. What is the reason for the emission of ions from the surface of charged ion or electron from the surface of the metal in thermionic emission process? Dear student, the reason of the emission of charged ions or electron from the surface of metal is quite simple. Please note that the electron reside on the surface of the metal. So electrons which reside on the surface of the metal have a certain work function. The work function is a minimum energy which binds the electron with the surface of the metal or with the surface of the solid. So the electron are basically bound to the surface of the metal because of the work function, because of the minimum energy. Okay, as you know that usually in atom, electron revolve around the nucleus. So the charge on the nucleus is plus. It is positive because the nucleus composed of proton and as well as neutrons, whereas the charge on electron is negative. So due to a difference between, or due to opposite charge, positive and negative charge, the electron are attracted by the nucleus. So due to this, electrons revolve around the nucleus. Now in metal, these electrons revolve over, or they move over the surface of the whole metal with respect to the nucleus of the metal elements. Okay, so the electron have a specific work function and they have a specific binding energy with the nucleus of the metal on which they are residing or on which they are moving. So when the heat is provided to the surface of the metal, if the heat energy is higher than the work function, or it is higher than the binding energy of electron with the nucleus of the atom of the metal, this will basically result into the emission of electrons from the surface of the metal, and this, due to this process is known as thermionic emission process. So now students, let us explain thermionic emission process with a simple example of sodium metal. Sodium is a metal having an atomic number 11 and its atomic weight is 23. So sodium basically have 11 electron which resides in an orbital in a specific shells and subshells. Dear students, consider the representation of the electrons of sodium with in shells, in a different shells by a schematic diagram. Usually, dear students, sodium atom or any element or any atom have a nucleus. So in a case of a sodium has 11 protons in its nucleus, whereas in a first shell of sodium it has 2 electrons. Okay, the shell is usually, it is known as an energy level, and the electron reside in orbit, which is usually a path of residing of an of electron. So the electron resides in a orbit or having a certain type of energy, and that energy is due to that energy electron are placed in a shell. Okay, so the electron having a same energy will basically have a same will be placed in a same shell. Okay, so in first shell there are two electron in sodium atom, whereas in second shell or in second energy level of atom there are 8 electron. However, the sodium is basically is very reactive because it has one electron in valence shell. Okay, so now dear student, the electron in a sodium atom, basically these electron reside, the electron move around the nucleus in a certain orbitals, and which may be represented by a schematic diagram as. So basically this is the this schematic basically represent the movement of the electron around the nucleus. Okay, so dear student, now in case if heat is provided by the from the external source, so like suppose if this sodium atom, this is the sodium atom, and this sodium atom is heated by external source, either by application of battery or either by generally by providing a heat, then the electron basically they of the valence electron will basically start to absorb the energy. So as you know dear student, the electron in every shell are basically representing the energy levels. So basically electron which are present in first shell, like this shell, they have a certain energy. Similarly, the electron which are present in a second shell, they have a specific energy which is associated with the energy of the shell. So now in the valence shell of the sodium there is one electron, and this electron has a certain energy, and due to this energy, due to this specific energy of the electron in valence shell, the electron is bounded with nucleus. Okay, so now when when the heat is provided from the external source, the valence electron will absorb energy which is higher than the energy of the electron to remain in the shell. So now due to external heat, the electron will have a higher energy. Due to higher energy, electron will start to jump from this shell to a higher energy level or to a higher shell. Similarly, dear student, if the additional heat is provided by external force to the electron which is in higher shell, the valence electron will have more energy than energy required by the electron to revolve in this higher shell. So when the energy of the electron become too high, then the energy required for the electron to reside, to remain in the shell, the electron will be ejected from this shell, and this electron is known as free electron. And the process of ejection of electron due to a heat is known as thermionic emission. Now, interesting question here is that why valence electron or why outermost electron in atom is easily ejected by a heat as compared to the electron which are present in the inner shells. The reason is quite simple, dear student. Please note that the electron which are closer to the nucleus, like these two electrons, they have stronger binding force with a nucleus. So it is very difficult for heat to remove the electron which are closer to the nucleus as compared to the electron which is away from the nucleus. Dear student, the force between the electron, like this valence electron and nucleus, is less as compared to the force between the electron which is in first shell and which is closer to the nucleus. So this force is basically known as nuclear interaction force. So the nuclear interaction force with electron which reside in inner shell is higher as compared to the electron which is present at outer valence shell. So for heat it is quite easy to remove the electron which is present at valence shell as compared to the electron which is present inside the inner shells. So when the electron are removed by the incorporation or by the application of heat, then the emission of electron are basically known as thermoelectrons, and the process is known as thermionic emission. So now very important question here to notice is that why thermionic emission is easy in metal. Why we can easily remove the electron from the surface of metal than the semiconductor material. What is the reason why thermionic emission is successful in metal as compared to the semiconductor materials? The reason is quite simple. The metal has a free electron which resides on the surface of the metal element. Okay, the electron in a metal are not localized with the proton of the nucleus. Basically, in metal, the electron moved everywhere across the metal surface. So the electron are lessly bound with the nucleus. Due to this reason, it is quite easy for heat to remove the delocalized electron or to eject the delocalized electrons. Whereas in case of semiconductor materials, the ejection of electron, usually the valence electron, is quite difficult because the electron or do not reside at the surface of the semiconductors, and they are localized with nucleus. So the interaction force of the nucleus with the electron in semiconductor is quite strong, or the binding force of the nucleus with the electron is quite strong as compared to the binding force of the nucleus with the electron in metals. Dear student, please note that one of the most interesting metals used in thermionic emission is known as tungsten metal. Tungsten is a metal which basically emit electron at very small amount at very low temperature. Though, dear student, please note that thermionic emission is usually take place above 1000 degrees centigrade. However, still, the good thing about the tungsten metal is that it emit electron it in efficient way it by application of very small potential and current. Even if you apply a 6 volt on tungsten metal and current of 3 ampere, tungsten can easily release electron by a process of thermionic emission. This is a reason that's why tungsten is one of the very important metal used in electron gun, and it is a very important metal which is used in a form of filament in electron beam evaporation and also in thermal evaporation processes. Dear student, the classical example of thermionic emission is the emission of electron from hot cathode in a vacuum tube. Okay, this is a classical example of thermionic emission. Let us represent the thermionic emission process in vacuum tube by a schematic representation. Consider this schematic represent a vacuum tube. The student, please note that vacuum tube is a tube which is evacuated. So vacuum tube operate at lower vacuum. The vacuum tube consists of electrode and cathode and as well as anode. Cathode is made of a material which basically is a metal, and it is connected with a negative terminal of the potential source, whereas the anode is connected with the positive terminal of the potential source. So charge on the cathode is negative, whereas charge on an anode is positive. So when a high potential is applied on, on the electrodes in a cathode ray tube, there will be created potential difference between the cathode and anode. And when the potential difference between the cathode and anode increase too much, then this will result into a heat of the cathode material. So when the cathode material is heated, the electron which reside on the surface of this cathode material will start to emit like this. And this emission of electron from this cathode surface will continue until the metal surface remain hot. So dear student, in a simple word, in cathode ray tube, high potential is applied on the electrodes, and due to a high potential, the cathode just heat up, and due to a heat, cathode start to emit the electron. So the emission of the electron due to a heat is basically thermionic emission. The cathode used in thermionic emission process is usually it's may be in a form of a metal filament. Most commonly used metal in for the emission of the electron in thermionic emission process is tungsten. Dear student, please note that the cathode may be made of different types of transition metals like carbide or borite. Okay, Apart from this, the metal filament or the metal which is used as a cathode may be coated with different types of coatings. Vacuum emission from the metal to become significant is usually at higher temperature, around 1000 degree Kelvin. So dear student, the emission of the electron in thermionic emission process becomes significant at higher temperature. So we need higher potential to emit, to heat the cathode rays, to heat the cathode material. And when the temperature of cathode material reach around 1000 degree Kelvin or around 730 degree Kelvin, the cathode material start to emit the significant, or start to eject the significant thermion or significant electron from its surface. Thermionic emission is crucial and important process, especially it is used in different types of electronic devices such as thermionic converters and electrodynamic detectors. So basically this method of thermionic emission is diverse and it is widely used in electronics devices. So student, this is all about the what is series of thermionic emission. In order, if you want to have a comprehensive understanding about the thermionic emission, you can basically follow our comprehensive lecture series about thermionic emission process. This lecture is a short overview of thermionic emission process. So in order to understand in-depthly, you need to follow our comprehensive lecture series about thermionic emission process. So thank you for watching this lecture.